41,000 years ago, an intriguing cosmic event altered human existence on Earth. Imagine a time when Earth's protective magnetic field faltered, exposing humanity to heightened levels of radiation. This extraordinary event compelled our ancestors to innovate means of protection, such as creating shelter, designing appropriate clothing, and utilizing minerals for safeguarding against harmful rays. When we first started our discussions, it felt a bit uneasy. In our group, there was an archaeologist with a keen interest in how ancient humans interacted with their surroundings, alongside two geophysicists who study the connections between solar phenomena and the Earth's magnetic field. Initially, we questioned whether our rather unconventional project, which aimed to connect the dots between cosmic weather and human behavior, could truly unify such distinct fields of study. However, after 2 years of collaboration, we are delighted to conclude that the rewards, both personal and scientific, have far outweighed those initial awkward moments. Our teamwork, which culminated in a recent publication in the esteemed journal Science Advances, was sparked by a singular question. What transpired on Earth when the magnetic field experienced a near collapse around 41,000 years ago? An anomaly in Earth's magnetic shield. This remarkable event, known as the Laschamps Excursion, represents a brief yet intense disruption in the geomagnetic field. Named after volcanic deposits in France, where it was first identified, this phenomenon occurred at the end of the Pleistocene epoch. Unlike typical geomagnetic reversals that happen every few hundred millennia, the magnetic poles during this excursion shifted erratically over thousands of miles, plummeting the magnetic field's strength to less than 10% of what we currently experience. Under standard conditions, Earth's magnetic field functions like a steady dipole, akin to a bar magnet. However, during the Laschamps excursion, this stability disintegrated into several weaker poles scattered around the globe. This breakdown compromised the magnetosphere, which ordinarily shields the planet from the solar wind and harmful ultraviolet radiation. With this vital shield weakened, models indicate that a range of phenomena likely emerged in proximity to Earth. Auroras, typically visible only within polar regions today, might have occurred much nearer to the equator during this time. Additionally, the Earth faced exposure to significantly higher solar radiation than what we encounter today. As a result, the skies around 41,000 years ago could have been both breathtaking and perilous. Understanding this scenario prompted us, as geophysicists, to ponder how these cosmic conditions might have influenced human populations at that time. How ancient humans responded to cosmic weather. From an archaeological viewpoint, it became clear that these people were, indeed, impacted by these extraordinary environmental changes. The auroras they witnessed would have been visually striking, likely stirring responses ranging from awe and fear to the development of rituals that are not easily detected in the archaeological record. While the direct evidence of such emotional reactions is scarce, we can glean insights from other data. The physiological impacts stemming from heightened ultraviolet exposure, however, are more straightforward to assess. With the magnetic field diminished, increased levels of harmful radiation reached Earth's surface, raising concerns about sunburns, eye damage, birth defects, and other health issues. In response, ancient humans might have taken practical steps to safeguard themselves, such as spending more time in caves, crafting better clothing for protection, or applying ochre, a mineral pigment, as a form of natural sunscreen on their skin. Our recent paper indicates that behaviors linked to these protective measures did indeed appear to rise significantly in certain regions of Europe during this time, where the repercussions of the Laschamps excursion were conspicuously marked. During this ancient period, both Neanderthals and Homo sapiens coexisted in Europe, albeit in overlapping territories. Archaeological evidence suggests that these groups reacted differently to the environmental challenges, with some relying more heavily on built structures and material culture for their protection. It's crucial to clarify that our research is not asserting that space weather singularly dictated behavioral changes, or that the Laschamps event was the sole cause of Neanderthal extinction. A common misunderstanding in discussions surrounding this topic Instead, it may represent one of numerous factors, a silent yet potent force that influenced human adaptability and creativity. The value of interdisciplinary collaboration. At first, collaborating across such significantly different disciplines was intimidating, but it quickly turned into a fulfilling experience. Archaeologists are skilled at piecing together now hidden phenomena, such as climate change. While direct measurements from the past are unattainable, we learn to interpret the traces left behind if we know how and when to search. However, even seasoned archaeologists who specialize in studying historical climate effects may not have fully considered the ramifications of geomagnetic activity and space weather. These factors, like climate influence, are invisible yet impactful and are best understood through indirect evidence and modeling. This integration allows archaeologists to incorporate space weather as a critical aspect of Earth's environmental history and future predictions. Conversely, geophysicists, who often analyze extensive datasets, simulations, and theoretical models, might overlook the human repercussions of space weather. Integrating archaeology breathes life into the scientific narrative, reminding us that the consequences of cosmic phenomena extend beyond the atmospheric layers, affecting human experiences directly and shaping their adaptability, creativity, and survival strategies. The Laschamps Excursion was not an isolated incident. Similar disruptions of Earth's magnetic field have occurred in the past and will likely occur again. By studying how ancient humans reacted to these changes, we gain valuable insights into how forthcoming events may impact our world and how we might prepare for such eventualities. Our unique partnership has unveiled the valuable lessons and shifts in perspective that arise when we transcend disciplinary boundaries. While space is incredibly vast, it also intimately connects us all. Often, a journey of forging connections between Earth and space begins with the smallest influences, such as ochre, clothing, or even a protective layer of sunscreen. References: Wandering of the Auroral Oval 41,000 Years Ago, by Agnit Mukhopadhyay, Sanja Panavska, Raven Garvey, Michael W. Limon, Natalia Ganjushkina, Austin Brenner, Ilya Usaskin, Mikhail Balakin, and Daniel T. Welling. April 16, 2025, Science Advances. DOE 10.1126, Science ADV.ADQ7275, adapted from an article originally published in The Conversation. Notice: Agnit Mukhopadhyay has received funding from NASA Science Mission Directorate and the University of Michigan Rackham Graduate School. Raven Garvey and Sanja Panavska state that they have no financial ties, shareholdings, or funding from any organizations that would gain from this article, apart from their academic roles.